We'll also many times be doing computations with numbers written in scientific form or scientific notation. In the process as we go through and do these, I'm going to multiply this component times its corresponding component. 4 times 2 is 8. And then I'm multiplying 10 to the 5th times 10 to the 9th. Remember, when you multiply like bases, you add the exponents. So my result here would be 10 to the 14th. Division will follow the same rules that we've had before. 1.2 divided by 4.8 gives me 1 over 4 times 10 to the 6th over 10 to the negative 3. When you divide like bases, you subtract the exponents. So 10 to the 6th minus a minus 3 gives me times 10 to the 9th power. And then likewise here, I'm going to multiply 5 times 10 to the negative 4. Since this is a multiplication problem in here, I can multiply that 3. That 3 goes to this part of it and also to that part. So I'll have 125 times 10, multiply the exponents, 10 to the negative 12. Now in this last problem, my result isn't in scientific notation. Remember, scientific notation states I have one number times the basis of 10. Well, both of these last two right here are not fully in scientific notation. So let's look at 1/4. That's 0.25 times 10 to the 9th. Remember, I need to have that decimal point after that first number. So the decimal point really should be 2.5 times 10. But times 10 to the what? Well, the way I look at it is 0.25, I made this number 10 times bigger. Therefore, I need to make this number 10 times smaller. So that result is 2.5 times 10 to the 8th. This one right here, my current decimal point's after the 5, but it should be after that 1. So correctly, it's going to be 1.25 times 10. I made 125 100 times smaller, so I need to make this number 100 times bigger, which will turn that into 12 to the negative 10th power, because negative 10 is larger than negative 12 in quantity. I know it's going to be confusing working with some of these negative numbers and exponents. That's why it's been so important for you to work on previous assignments where we've talked about the ideas of negative numbers in their exponent positions. That way, when we're starting to work with some applications, we can understand the application. Not because we're getting bogged down in some of the math. We're learning the math part. Now we can start to understand the application of how that's being used.